Hello and welcome to this tech tip from Will. In this tech tip, I will be looking at NIC Teaming for Windows Server 2012 and Windows Server 2012 R2. First, I will provide you with an overview of NIC Teaming and will then take a look at how it works. Next, I will look at the different methods of configuring NIC Teaming. And finally, I will demonstrate how to implement and configure NIC Teaming on my Windows Server 2012 R2 server. So let's get started. So, first things first, what exactly is NIC Teaming? NIC Teaming is a brand new feature that was first introduced in Windows Server 2012 and was enhanced further in Windows Server 2012 R2. Depending on which literature you read, NIC Teaming is also referred to as load balancing and failover, or simply LBFO. NIC Teaming, in a nutshell, is a technology that allows you to combine multiple network adapters together. When you use NIC Teaming to combine network adapters, these adapters are placed into what is called a NIC team, or simply just a team. With NIC Teaming in Windows Server 2012 and Windows Server 2012 R2, you can combine up to 32 network adapters together to form the one team. It is worth noting at this point that NIC Teaming is only supported on Ethernet network adapters. You cannot, for instance, implement NIC Teaming on network adapters that use alternative technologies, such as Wi-Fi or Bluetooth. Of course, you may be asking at this point, why would I want to create a team of network adapters? Well, there are a couple of reasons. The first reason is for bandwidth aggregation, also known as load balancing. With bandwidth aggregation, you are able to combine the bandwidth of your network adapters together into one large connection. Bandwidth aggregation is designed to give the server more throughput. For instance, imagine that you have a server running either Windows Server 2012 or Windows Server 2012 R2. Let's say that this server has 3 network adapters installed. All adapters are operating at a speed of 1 gigabit per second. With bandwidth aggregation, all of the adapters in the NIC team are placed into what is called the active state. When a network adapter is active, it is actually sending and receiving network traffic. Bandwidth aggregation essentially allows the bandwidth of the 3 adapters to be combined, giving the server a single 3 gigabit per second connection to the network. If one of the physical adapters in the team were to fail, the connection will remain up, but will operate at a reduced speed of 2 gigabits per second. The second reason for implementing NIC Teaming is for failover reasons. With failover, one of the adapters in the team is held in reserve. That is, despite being a member of the team, the adapter does not actually contribute any bandwidth to the team. The reserve adapter is known as a standby adapter. The point of failover is to give you redundancy on your server's network connection. That is, if one of the active adapters in the NIC team were to fail, the standby adapter will become active and will take the place of the failed adapter. For example, let's consider the same server from before. Again, the server is running either Windows Server 2012 or Windows Server 2012 R2 and has 3 network adapters installed, all of which are operating at a speed of 1 gigabit per second. With a failover configuration, once again, all 3 adapters are combined into a team. However, only 2 of the adapters are marked as active and are contributing bandwidth. The third network adapter, meanwhile, is marked as standby. This adapter is kept in reserve and will only contribute bandwidth if one of the active adapters were to fail. This essentially means that the server will only ever be capable of a 2 gigabit per second connection to the network. However, if an adapter is lost to hardware failure, you can rest assured that the standby adapter will kick in automatically and your 2 gigabit per second connection to the network will be maintained. One question I am asked by a lot of new technicians is, can you create a team of network adapters that operate at different speeds? And the answer is, it depends. As a general rule of thumb, and to make your life easier, you should ensure, where possible, that all of the adapters in your NIC team are the same speed. Although it is possible to create a NIC team using different speed adapters, this configuration is not recommended nor supported by Microsoft. The reason why this is not supported is because the speed of the adapters does not determine how network traffic is load balanced. For instance, let's say that you have a server with 2 network adapters, one operating at 1 gigabit per second and the other at 100 megabits per second. These adapters are combined into a NIC team and both cards are active, meaning they are both routing network traffic. When traffic is sent from the server, the traffic is, in theory, split evenly between the 2 adapters. The fact that the second adapter is only capable of 100 megabits per second does not mean it will receive less traffic. On a very busy server, it is only a matter of time before the slower adapter becomes overwhelmed. Having said all this, there are a couple of exceptions to this rule, where different speed adapters can be used. If you are interested in bandwidth aggregation, one option is to use network adapters that can be configured to operate at different speeds. That is, some network cards actually allow you to change the speed of the adapter. If we take our earlier example of a server with 2 active network adapters operating at different speeds, if we were to configure the 1 gigabit per second adapter directly so that the speed is dropped to 100 megabits per second, both adapters in the team will now be operating at the same speed. This brings the configuration back into compliance with Microsoft, but does mean that you are sacrificing bandwidth. On the other hand, if you are interested in failover, the only alternative you have is to create a NIC team that has just 2 network adapters. In this configuration, you should make the quicker of the 2 adapters the active team member, and the slower adapter the standby adapter. With this setup, only one adapter can be active at any one time. If the active adapter fails, the standby adapter will kick in and will maintain the connection, albeit at a lower speed. Since you do not have 2 active adapters running side by side at different speeds at the same time, this configuration is still supported. As you can see, there is no perfect workaround to using different speed adapters. For that reason, personally, I would only ever consider NIC teaming if the adapters in the server are the same speed. This is the easiest solution. Now that we know the reasons for implementing NIC teaming, let's now take a look at exactly how the technology works. Although NIC Teaming is a brand new feature to Windows Server 2012, the technology itself is not brand new and has actually existed for a number of years. Windows Server 2012 is the first version of Windows to come with NIC Teaming actually built into the operating system. If you wanted to use NIC Teaming prior to Windows Server 2012, you would have no choice but to use a third-party product. The NIC Teaming feature included with Windows Server 2012 and Windows Server 2012 R2 allows NIC Teaming to be configured from the software layer. This provides a number of advantages. First, it means that the administrator is not required to purchase any special network adapters to get the feature to work. With NIC Teaming, you can create a team using network adapters from practically any hardware vendor. It is worth noting at this point that it is recommended that you use network adapters from the same vendor if possible, but this is not essential. Also, the administrator is not required to make any complex configurations on the network adapters themselves. Everything you need to configure your adapters for NIC Teaming is included with Windows Server 2012. So, how exactly does Windows create the NIC team? To understand this, let's look at an example. Imagine that you have a server running either Windows Server 2012 or Windows Server 2012 R2. This server has a number of network cards installed. In order to combine the adapters into a team, Windows will use what is called a teaming solution. The job of the teaming solution is to create a single virtual network adapter out of the 4 physical network adapters. The virtual network adapter is then presented to the operating system. In other words, the operating system is fooled by the teaming solution into thinking that there is just one network adapter installed in the server. Just like with a physical network adapter, the administrator is then able to assign the virtual network adapter an IP address. Any traffic sent to and from this IP address will then be distributed across all of the physical adapters in the team. Of course, this is largely dependent on how you set up and configure your NIC team. Before you implement NIC Teaming on your servers, the first decision you have to make is which teaming mode you want to use. There are 2 main types of teaming modes available. These are switch-independent teaming or switch-dependent teaming. The main difference between the 2 teaming modes is that switch-independent teaming requires no additional hardware support from the switches on your network. Switch-dependent teaming, however, is, as the name suggests, dependent on your network switches being configured correctly. Let's start by taking a closer look at switch-independent teaming. Switch-independent teaming is the easiest and arguably the most common form of NIC teaming available. What makes switch-independent teaming so appealing is that all of the configuration for the NIC team is done on the server itself. Absolutely no configuration of the network switches is required to get switch-independent teaming to work. With switch-independent teaming, the switches on your network are completely unaware that the NIC team even exists. Another reason why administrators may opt for switch-independent teaming is that you are able to connect the adapters in your NIC team to different switches. For instance, if you have a server with 3 network adapters configured in a team, as long as switch-independent teaming is used, you are able to connect the adapters to 3 different switches. This provides you with an additional layer of redundancy, because if one of the switches were to fail, the server is still able to communicate with the rest of the network using the other switches. Understand, switch-independent teaming does not require the use of multiple switches, it merely makes it possible. There is nothing stopping you from connecting all 3 adapters to the same switch if you really wanted to. The disadvantage of switch-independent teaming is that all inbound and outbound traffic for the NIC team is managed entirely by Windows. Generally speaking, Windows is better at managing outbound traffic than incoming traffic. However, Windows is not always capable of making the most intelligent decisions for balancing traffic evenly. As a result, some of your adapters could be more heavily utilized than others. This is why some network administrators prefer to use other configurations, such as switch-dependent teaming. There are 2 types of switch-dependent teaming. The first is static teaming, and the second is LACP, or Link Aggregation Control Protocol. Both static teaming and LACP require hardware support from the network switch in order to work. That is, the administrator is, quite literally, required to log on to the switch and configure it accordingly. This makes static teaming and LACP harder to implement. Static teaming uses the protocol 802.3AD to nominate specific ports on the switch that can be used for NIC teaming. LACP does the same, except it uses the protocol 802.1AX. Unsurprisingly, this means 2 things. First, static teaming and LACP allow you to use just one network switch. That is, all of your adapters must be plugged into the same switch. It is not possible to achieve redundancy at the switch level if you opt for switch-dependent teaming. Also, since the ports on the switch themselves are statically configured, the network adapters that make up the NIC team must be plugged into the correct ports. Unlike switch-independent teaming, when switch-dependent teaming is used, the switch is fully aware of the NIC team's existence. The main advantage of switch-dependent teaming is that the switch is able to assist the NIC team by load balancing incoming traffic among all of the adapters in the team. That is, incoming traffic should, in theory, be distributed evenly amongst all the adapters. Load balancing of incoming traffic is something that Windows struggles to achieve by itself with switch-independent teaming. Of course, all of this is dependent on your network switch supporting static teaming and/or LACP. Some switches do not support it at all. Others may support just one of these modes, and others will support both. Since it is not possible for me to demonstrate how to configure static teaming and LACP on every single model of switch, later in the video, when I demonstrate NIC teaming to you, I will stick to switch-independent teaming. Now that we are familiar with the available teaming modes, the next topic to discuss is load balancing modes. Load balancing modes determine how network traffic is load balanced, that is, how it is divided up among the network adapters in the NIC team. Before we go through the different load balancing modes, it is important to understand that with any load balancing mode, Microsoft has attempted to keep all data packets associated with the same TCP stream on the same network adapter. But what exactly do I mean by this? Well, let's consider an example. Let's say that you have a server running either Windows Server 2012 or Windows Server 2012 R2. This server is a very busy file server, hosting thousands of shared folders. When a client computer requests a file from the file server, before the file is transferred to the client, it is first broken down into smaller segments. These segments are called packets. Since these packets make up the same file, they are considered to be part of the same TCP stream during transportation. The problem is, if these packets are sent out over different network adapters, there is no way of telling what order the packets will arrive in when they get to their destination. That is, it is possible for packets to arrive out of order. When this happens, the out-of-order packets will have to be reordered once they arrive at the client. This, of course, requires more processor power and RAM memory from the client. To stop this from happening, all of the load balancing modes in NIC Teaming will attempt to send all packets that belong to the same TCP stream over the same network adapter, increasing the chances that they arrive in order. Let's now take a look at the different load balancing algorithms. The first load balancing mode is called address hash. With address hash, all of the outbound network traffic, that is, traffic that is sent out from the server, is load balanced based on properties taken from the destination computer, such as the destination computer's MAC address, IP address, or even port numbers. To demonstrate this better, let's go back to our file server from earlier. Let's say that a client computer named Client1 requires access to a file hosted on the file server. Client1 has a MAC address of 0015D010100 and an IP address of 192.168.1.100. When Client1 requests the file from the file server, Windows will use Client1's MAC address and IP address to create what is called a hash, or a number. All of the packets that make up the file are then marked with this hash value. For demonstration purposes, I have illustrated this as hash 1234. All data packets that have the hash value of hash 1234 are considered to have the same destination. Consequently, these packets will be sent out using the same network adapter in the team. When a new client computer named Client2 comes along, the MAC address and IP address of this computer will be different. As such, when Client2 requests a file, Windows will generate a completely different hash value and will send this traffic via a different network adapter in the team. As more clients come along, these will also be assigned their own hash values and will be allocated an adapter. In short, address hash ensures that all TCP streams for a particular computer always use the same network adapter, but will split the streams up as much as possible over different adapters. As you can see, address hash is very good at dividing up TCP streams. However, it does not always guarantee the best load balancing solution. For instance, if Client 2 and Client 4 have a habit of requesting much larger files more frequently than Client 1 and Client 3, it stands to reason that the adapter assigned to Clients 2 and 4 will be more heavily utilised. Let's now take a look at inbound traffic. With address hash, all traffic that is sent to the server will arrive via the same network adapter. It does not matter whether you have just 2 adapters or 32 adapters in the NIC team. Traffic will always be delivered to the server via just one of these adapters. This essentially means that, with this algorithm, the server can only accept as much traffic as the bandwidth on one of the adapters allow. The next load balancing mode is HyperV Port. As the name suggests, HyperV Port was designed for servers hosting Hyper-V virtual machines. With HyperV Port, every virtual machine that uses the NIC team will send and receive all of its traffic via the same network adapter. This is achieved using the MAC address of the virtual machine. For instance, imagine that you have a server that has the Hyper-V role installed. This server has 3 virtual machines, each with their own MAC address. The server also has 3 network adapters that have been combined together into a NIC team. On the server, you create a virtual switch from the teamed adapter and attach all 3 virtual machines to it. What essentially happens here is each virtual machine is allocated a network adapter from the team to send and receive its traffic. Since there are 3 adapters in this particular NIC team, every virtual machine gets its own adapter. If a 4th virtual machine is later added, this virtual machine will, like the others, be assigned an adapter to route its traffic. When this is the case, 2 virtual machines will have no choice but to share the same adapter. Although HyperV Port is very good at load balancing traffic at the virtual machine level, perfect load balancing is still not guaranteed. For instance, it is possible that the 2 virtual machines that share the same adapter could be very bandwidth-intensive machines. Meanwhile, the other 2 virtuals that have their own adapters may not utilize the bandwidth so much. As such, HyperV Port is best used when you are running virtual machines that have similar bandwidth requirements. One argument for HyperV Port, though, is that it does, to some degree, provide load balancing for incoming traffic, since each virtual machine also receives its traffic from its allocated network adapter. The only limitation to HyperV Port is that it is designed specifically for virtual machines. The final load balancing mode to discuss is dynamic. The dynamic load balancing algorithm is only available if you are using Windows Server 2012 R2. Dynamic load balancing was added as an improvement to NIC teaming by combining certain aspects of address hash and HyperV Port into one mode. Let's start by looking at outbound traffic. Dynamic load balancing handles outbound traffic in the same way as address hash. That is, outbound traffic is load balanced across the adapters based on a hash value that is calculated from either the MAC address, IP address, or port numbers of the destination computer. What makes dynamic particularly appealing is that, unlike with address hash, it is able to redirect TCP streams to different adapters. That is, if one network adapter is particularly overwhelmed, Dynamic is able to shift some of the TCP streams onto a different adapter. To visualize this better, let's take the example of a busy email server. This server has 2 network adapters that are combined into a NIC team. At present, there are 2 TCP streams, one on each adapter, sending data packets over the network. However, you can clearly see that the TCP stream on the first adapter is very large, and the TCP stream on the second adapter is not so large. If a third TCP stream were to commence, dynamic load balancing is intelligent enough to have this TCP stream use the second adapter, since this is not being utilized as much. Likewise, if the TCP streams on the first adapter were to subside to the point where it is now being underutilized, dynamic load balancing will address this by shifting some of the TCP streams from the second adapter over to the first. Dynamic load balancing is able to detect when a network adapter is underused by looking for what are called flowlets in TCP streams. A flowlet is a brief but natural pause in network traffic. That is, during a TCP stream, packets will be sent, followed by a brief pause, then more packets will be sent, followed by another brief pause, and then followed by more packets. Every TCP stream has flowlets that occur naturally. Flowlets are completely normal and are by design. By measuring the amount of flowlets on a network card, dynamic load balancing is able to make an educated guess on when it is best to shift TCP streams to different adapters. With regards to incoming traffic, dynamic load balancing handles incoming traffic in the same way as HyperV Port, meaning that dynamic is fully optimized for use in a Hyper-V environment. Now that we have covered the different methods of configuring NIC teaming, let's now take a look at how to set it up. I will now change over to my Windows Server 2012 R2 server so that I can demonstrate how to set up and configure NIC teaming. This is a clean installation of Windows Server 2012 R2, straight out of the box. The only configuration I have made is changing the host name of the server to Server 1. To begin with, I will open Server Manager and will select Local Server from the top left corner. In the Properties section at the top, notice that there is an option for NIC teaming and that the feature is disabled by default. Beneath this, you can see all of the individual network adapters that are installed in this server. In my case, I have 3 network adapters installed, named Ethernet, Ethernet 2, and Ethernet 3. Since this is a clean installation of Windows Server 2012 R2, all of the adapters are set to receive IPv4 addresses via DHCP, which is the default configuration. IPv6 is also enabled. Let's now take a closer look at the 3 network adapters by opening Network Connections. As you can see, my 3 network adapters, Ethernet, Ethernet 2, and Ethernet 3, have all appeared listed. To view the configuration of a network adapter, simply right-click on it and select Properties, which I will do now for my Ethernet adapter. From the list of items, notice that I am able to configure either an IPv4 or an IPv6 address. However, notice that there is one item which is unticked, called the Microsoft Network Adapter Multiplexer Protocol. This is essentially the protocol that Microsoft uses to provide load balancing and failover capability for network adapters. This is also the protocol that is used to combine the adapters into a NIC team. Since NIC teaming is disabled by default, it makes sense that this protocol would also be disabled. To prove that this is the case for all of my adapters, I will close the properties of my Ethernet adapter and will open the properties for my Ethernet 2 adapter and for my Ethernet 3 adapter. you can clearly see that the Microsoft Network Adapter Multiplexer protocol is disabled for all of the adapters. I will now close out of Network Connections and will return to Server Manager. To enable NIC Teaming for Windows Server 2012 and Windows Server 2012 R2, click on the disabled link next to the option in Server Manager. This opens the NIC Teaming dialog box. To create a NIC team, you first have to select which server you want to create the team on. This can be done from the Servers section at the top. Since this is the only server I have added to my Server Manager console, it is selected by default. In the bottom right corner, notice that we have a section named Adapters and Interfaces. This section shows you which adapters in the server are currently part of a NIC team, and those which can be added to a NIC team if you wish. Since I do not yet have a NIC team, all of my adapters are listed as available to be added to a team. Finally, in the bottom left corner, we have the section Teams. This is where the NIC teams are listed. That is, once you have created a NIC team, it will appear in this section. Since I do not currently have a NIC team, nothing is listed. To create your first NIC team, in the Teams section, click on the Tasks button and select New Team from the drop-down list. This opens the New Team dialog box. To create a NIC team, the first thing you must do is choose a team name to identify it. For now, I will enter a team name of Server 1, NIC Team 1. After choosing a name, the next task is to decide which adapters will be made members of the NIC team. As you can see, my 3 network adapters, Ethernet, Ethernet 2 and Ethernet 3, are all listed as possible candidates. To add an adapter to the team, simply tick the checkbox to the left of the adapter. For now, I will add my Ethernet and Ethernet 2 network adapters to the team. After choosing your adapters, click the Additional Properties link. From here, you are able to configure the advanced features of NIC Teaming. The first option allows you to choose a teaming mode. By default, this is set to switch independent, which, if you recall, allows you to connect your adapters to different switches. However, you can modify this to use one of the switch-dependent modes of static teaming or LACP instead. Of course, both of these will involve some configuration of the network switch itself. For now, I will leave this on switch independent. Next, you can choose the load balancing mode. On Windows Server 2012 servers, you can choose between address hash or HyperV Port. On Windows Server 2012 R2 servers, you also get an additional option of dynamic. Choosing a load balancing mode is simply a matter of selecting it from the drop-down list. The last option, Standby Adapter, determines whether or not you want one of your nominated network adapters to function as a standby adapter. If you recall from earlier, the job of a standby adapter is to sit and wait for an active network adapter to fail. When an active network adapter fails, the standby adapter will step in and take its place. By default, Windows will attempt to make all of your network adapters active to increase the throughput of the server. However, if you would rather use NIC Teaming with a standby adapter, you are able to choose one of your nominated adapters from the drop-down list to function as a standby adapter. Personally, I am a fan of keeping all adapters in the NIC team active for maximum performance, so I will leave this on None, all adapters active, and will then click the OK button. After a short wait, Windows will create the NIC team. It is worth noting at this point that, rather curiously, when the NIC team is first created, you may find that one or more of your adapters will report a status of faulted connection pending, and your NIC team will appear to have problems. If this happens, do not panic. I have created a lot of NIC teams and have found that it can take up to 30 seconds before the team is properly established and the adapters report the correct status. Once the NIC team has been created, you will immediately notice a few changes to the NIC teaming screen. First, notice that in the Teams section, our Server 1 NIC Team 1 team has now appeared and is reporting a status of OK. Also, in the Adapters and Interfaces section, notice that my Ethernet and Ethernet 2 network adapters are listed under a new heading of Server 1 NIC Team 1, indicating that they are now part of a NIC team. Furthermore, both adapters are reporting a state of active, whereas my Ethernet 3 adapter is still listed as available to be added to a team. I will now close the NIC Teaming dialog box and will return to Server Manager. From here, you will notice a few more changes. Firstly, we can see that NIC Teaming is now enabled on this server. Also note that my Ethernet and Ethernet 2 adapters have disappeared and have been replaced with my Server 1 NIC Team 1 connection. Since Ethernet 3 is not part of the team, it is still listed separately. Let's now take a closer look at the network cards by opening Network Connections. The first thing that should be evident on this screen is that our Server 1 NIC Team 1 connection has appeared listed. Before I look at this though, I would first like to take a closer look at my Ethernet and Ethernet 2 adapters, so I will right-click on my Ethernet adapter and will select Properties. Since my Ethernet adapter is now part of a NIC team, you will notice that all of the items from earlier are now unticked. Also note that I have lost the ability to configure an IPv4 and an IPv6 address on this adapter. In fact, the only item that is now ticked is the Microsoft Network Adapter Multiplexer protocol I mentioned earlier. If you recall, this is the protocol that allows the adapter to be used for load balancing and failover in NIC teaming. Since the adapter is now part of a NIC team, it makes sense that this will be enabled. This is also the case for my Ethernet 2 adapter. So I will now close the Properties screen and will return to Network Connections. Let's now take a closer look at my Server 1 NIC Team 1 adapter. First, I will right-click on the adapter and will select Status. Notice that the speed of this adapter is 2 gigabits per second. This is the combined bandwidth from my Ethernet and Ethernet 2 adapters. I will now close the status screen and will open the properties for the adapter. Notice on this adapter, I am able to configure an IPv4 or IPv6 address. Since it is a good practice to configure servers with static IP addresses, I will enter a static IPv4 address on this adapter. Once complete, I will close out of the Properties and Network Connection screens and will return to Server Manager. Notice now that Server Manager has picked up the static IPv4 address I just entered. Now that the NIC team is enabled and configured, I will now go back into the NIC Teaming console so that I can simulate a network card failure. As you can see in the Adapters and Interfaces section, both my Ethernet and Ethernet 2 adapters are currently active. To prove that I have network connectivity, I will now open a command prompt from the Start button. From here, I will ping another computer on my local area network. As you can see, I have successfully pinged the computer and have received 4 replies. I will now simulate a network card failure by unplugging my Ethernet network adapter. As you can see, the status of my Ethernet network adapter has changed to faulted media disconnected. Yet the status of my Ethernet 2 adapter is still active. Assuming that NIC Teaming has been properly configured, this server, despite the network card failure, should still be able to communicate with the rest of the network. So let's find out. Back on my command prompt window, I will once again ping the same computer from earlier. As you can see, I am still getting replies, indicating that network connectivity is still present. So I will now close the command prompt and will plug my Ethernet adapter back in. After a short wait, the status of my Ethernet adapter will change back to active. The next demonstration I would like to perform is how to add network adapters to an existing NIC team. This is relatively easy to do. First, I will right-click on my Server 1 NIC Team 1 team and will select Properties. This will open the Team Properties dialog box. In my case, I will add my Ethernet 3 network adapter to the team. To make this adapter part of the team, I will simply tick the checkbox to the left of the adapter, and will then click the Apply button. After a short wait, the adapter will be added to the team. By default, Windows will add the adapter as an active adapter. However, just for demonstration purposes, I will make my Ethernet 3 adapter a standby network adapter instead. To do this, I will open the Additional Properties section, and for the standby adapter setting, I will nominate Ethernet 3 as my standby adapter. This essentially means that Ethernet 3 will no longer contribute any bandwidth to the NIC team unless either the Ethernet or Ethernet 2 network adapters fail. To change the adapter to a standby adapter, I will just click OK. Back on the NIC Teaming screen, in the Adapters and Interfaces section, notice that my Ethernet 3 adapter is now listed under the Server 1 NIC Team 1 team and is reporting a status of standby. To show you how the standby adapter works, I will once again unplug my Ethernet network adapter. As you can see, my Ethernet network adapter is once again reporting a status of faulted media disconnected. To compensate for the loss of bandwidth, my Ethernet 3 adapter has stepped in and has changed from standby to active. Notice what happens when I plug my Ethernet adapter back in. After a short wait, the Ethernet adapter will change back to active, and the Ethernet 3 adapter will return to standby. The final thing I would like to show you is how to delete a NIC team. To delete a NIC team, all you have to do, in the Teams section, is right-click on the team and select Delete from the drop-down list. At this point, you will receive a prompt asking you to confirm the deletion of the NIC team. To delete the team, click the Delete Team button. After a short wait, the team will be removed from the Teams section, and the adapters will return to their original state of available to be added to a team. If I close the NIC Teaming dialog box and return to Server Manager, you will notice that NIC Teaming is once again disabled. Furthermore, my Ethernet, Ethernet 2 and Ethernet 3 adapters are once again listed as individual adapters, which can be configured separately. To prove that this is definitely the case, I will open Network Connections. As you can see, the Server 1 NIC Team 1 connection has now disappeared, and I am once again able to configure my individual adapters separately. This concludes this tech tip from Will. I hope you have enjoyed this tech tip from us. For more tech tips, please feel free to browse our collection of videos on YouTube. And don't forget to show your support by liking our videos, leaving your comments, and by subscribing to our channel. Many thanks, and we'll see you on the next tech tip.